Hello everyone, I'm Jorge Romero, PhD student at the University of Manchester. Thanks for attending this presentation on the Syn-eruptive collapses experienced by the recently formed edifice of Cumbre Vieja volcano. This is a collective work between several institutions collaborating with Involcan during the 2021 eruptive crisis. The west side of the Cumbre Vieja ridge is steep, and before the 2021 eruption, the surface had 26 degrees of slope inclination. In part, the area occupied by the new northwest-southeast trending fissure corresponded to a Holocene bridge cone. This is a factor contributing gravitational stability. The 2021 eruption of Cumbre Vieja volcano, La Palma Island, combined both explosive and effusive activity, intercalating lava fontaining, strombolian activity, and ash venting events. The total volume of tephra reached 23 million cubic meters, and the proximal deposition of coarse products edified a 200 meters high irregular cone. Spatter piled up around the active vents, leading to a rapid edifice growth. During the first days of eruption, the cone grew up more than 100 meters and lava drained to the southwest, thus producing a bridge cone. A paucity in the lava fusion ceased its flow, then allowing incandescent material to build up, forming the west flank of the cone. The west flank experienced at least two types of lateral collapses. Small landslides start occurring after 5 days of eruption, and in September the 25th, a major failure of all the west flank modified substantially the morphology of the cone. As a result, decametric fragments of the edifice were deposited away, as well as raft-bearing lavas affected the southwest. Soon after, several smaller landslides affected the accumulations of hot spatter between the vents, the so-called ramparts, mostly during the first month of eruption. These small events triggered violent lava overflows, transporting metric rafts on top. Throughout the analysis of thermal and visible images of static surveillance cameras, as well as field observations and textural investigation of pyroclastic products, we determined the major collapse of September was conditioned by rapid pyroclastic accumulation and the reactivation of the southwest lava flow. The latter acted as a lava seep, triggering the rotational slide of the west flank. The failure was not instantaneous, but progressive. The images from the cameras were useful to measure two-dimensional speeds from 34 to 70 meters per hour for the largest landslide blocks. The intense shear between these partially solidified fragments led to characteristic ash formation, which has been recognized in the most proximal tephra fault deposits. With the help of a digital surface model made by drone 2 days after the collapse, we recognize a prominent scar of 200 by 450 meters. The cone lost about 5.5 million cubic meters, and the largest fragments were deposited up to 700 meters to the west. The raft-bearing lavas form prominent levees and a central channel up to 70 meters width. This lava, despite mafic and fluid, resembled a viscous morphology. It is prominent, and its size blocked other lava flows to the southwest almost to the end of the eruption. We have only captured the subsequent smaller flank collapse events by direct observation and thermal imaging. Using chronologic observations as in early October, we can notice how the regenerated west flank rapidly accumulates spatter and forms ramparts between the different vents. These ramparts collapse and produce fan-shaped lava overflows, transporting metric rolling blocks. The rapid transformation of the cone morphology, as shown in thermal images, is a factor increasing hazard of a sudden lava overflow. Hence, forecasting lava inundation and flank instability becomes a challenging task. We still have many things to learn from Cumbre Vieja and its recent eruption. This case study will allow comprehending much better the formation and destruction of small volcanoes. Please remain in this session as other related talks come soon. Thank you for watching. Do you have any questions?